Okay, so I'm joined today by Chris Saenz, who is the Segment Development Manager of Biomanufacturing North America for Beckman Coulter Life Sciences. And he's here to tell us about the company, its role in alternative proteins, as well as some of the products the company offers innovators in the sector. Chris, welcome to Protein Production Technology International.
Hi, how's it going, Nick? Thank you for
Yeah,
having me.
going great, going great. Lovely to have you. Before we dive into the specifics of Beckman Coulter Life Sciences tech, I'm intrigued to learn about you and your perspective. Could you tell me a bit about your role and what you've observed in the alternative proteins industry as a whole in recent times?
Oh, certainly. All right. So, as a segment development manager here at Beckman Coulter, specifically for the biomanufacturing space, what that means is I professionally go on field trips. I absolutely love my job. I get to go out in the field and speak with scientists in this space and see really where their gaps are, where their pain points are, really what's keeping people up at night to make sure that what we're doing, what we have on our product roadmap really is aligned with what the market wants,
Uh-huh.
as well as, use those ideas for guiding future product development.
Uh-huh.
In addition to that, I get to see what the general market sentiment is around our existing products, as well as, just learn the science of the field. I'm a scientist by training, and
Uh-huh.
so it really gets to scratch that itch for me, which is one of my favorite things.
Now, one of the sectors you work with is precision fermentation, which is revolutionizing the food industry, or is poised to revolutionize the food industry. With a growing emphasis on sustainable and alternative food sources, the demand for precise control over fermentation processes is rocketing. So, how are you as a company positioning yourselves to meet this escalating demand and driving innovation in the food sector?
When Beckman Coulter Life Sciences looks at innovation, we really grow via two pathways. One is our in-house development team, and we have a great set of R&D teams. The other method is by strategic acquisition. And within the precision fermentation space, one of our more recent acquisitions was M2P Labs out of Aachen, Germany. I know I butchered the pronunciation there, but it is a plate-based fermentation platform for screening 48 microbes at once.
Uh-huh.
And really what we're looking at doing is really accelerating everything upstream for organism engineers in this field.
Mhm. We're going to discuss some of the products a bit later on. Is it possible to give me just rewinding it a little bit, is it possible to give me a brief history of the company, Beckman Coulter, some of its tech milestones, and perhaps tell us when you personally first started recognizing the potential of alternative proteins as a subsect of the food sector?
Sure. Actually, so Beckman Coulter Life Sciences is a much older company than most people think it is. It was founded in 1935 by Arnold Beckman. He was a Caltech professor at the time. And one of the products that he was contracted to make was by the Sunkist Citrus Company, which is the pH meter. They were going to look at acidity in their citrus fruits. So one could say we've always been in the food space. What made me really interested in this space, I'm located here in Northern California, in the Central Valley, and a lot of the food, a lot of the small startups that are springing up out of the UC Davis ecosystem are in this food space. And so for the past couple of years, 4 or 5 years, I've been really interested in it. I've been very passionate about this. And, the case was made for a team dedicated to looking at this suite of companies. My team of 4 people has been really going out to make sure that we are better understanding clients in this space.
Mhm. Now, what are the key challenges and opportunities that you see in the food industry that align with Beckman Coulter's core competencies?
Beckman Coulter has been in the bioengineering space for many, many years. This is our bread and butter. We are excellent at providing tools for the life sciences market. And where we see ourselves in the space is we really see a way to accelerate all that upstream organism engineering. We've been doing it for a while in other adjacent spaces. We have something called the Echo, which is an acoustic liquid handler for very small volume transfers. That's a 25 nanoliter transfer. And, for things like Golden Gate or Gibson assemblies, CRISPR screening, really any of that molecular biology engineering is really in our wheelhouse. So when we look at these adjacent fields, when we look at industrial enzymology, we look at the food space. We've been doing this for a while, and so as much as we're experts sort of writ large in the life sciences space, we are building muscle to continue to grow here, because no one will ever be the expert that the people who are sitting across the lab bench are. These are people who eat, live, sleep, and breathe their target molecules, their products, and so we have a lot to learn from them. Make sure that we're providing the right thing to again accelerate that upstream organism development.
Let's drill down now into some of those products, the workflow solutions. And what specific technologies or platforms do you offer to support the development of all proteins and sustainable food systems?
Sure. So I mentioned that Echo, really best in class for genomic editing. We also have a tip-based liquid handler that can be abutted to, and that would be the Biomech line. And so when you're looking at developing your plasmids, we can completely walk away that workflow by attaching that to a traditional tip-based liquid handler, where you can come back to almost spotted colonies, by passing that back to the Echo. We have a great little photograph that we've done with another company in that space. But the tip-based liquid handler, our Echo acoustic liquid handler, I mentioned that plate-based biolector system that we'll be speaking about a little bit more later. But being able to generate all of those clones, then screen those clones, and then use our complement of flow cytometers to start looking at what are our absolute highest producers. We do have a really buttoned up workflow in this space.
Now, the BioLector XT, I think, can you discuss the potential of that in optimizing fermentation processes for applications such as dairy alternatives or plant-based meat substitutes?
Sure. And, one of the things that people in this space are doing, you're generating, dozens, if not hundreds of clones when you are looking for what is the best way of developing my candidate molecule. And so with the BioLector XT, one thing that we can do is one plate DOE for things like feeding strategies, one plate DOE, design of experiment, for media optimization. Or even that first pass of which ones are my high producers with a built-in fluorescence detector on the BioLector XT. One thing that we can do is see, where's my fluorophore glowing the brightest, and maybe that's my high producer. So being able to do this one shot in one plate, whereas traditionally, you'll have a bank of bioreactors running down the length of a cell culture hood. This is a way of being a little bit more impactful and being a little bit more having a greater likelihood of a shot on target once you get to that scale. As we're able to do that first screen.
And how does that technology help innovators in the sector accelerate the R&D of their ingredients or additives derived from fermentation?
I mean, you're able to weed out which ones are your losers and which ones are your winners really quickly, and really identifying your winners really quickly and identifying your optimum feeding strategy and media formulation for those winners right off the bat is definitely makes things easier down the line. You want to hit that win condition as early as possible.
Now, the Biomech i5, I think you previously mentioned that, designed for medium to high throughput workflows. How does that contribute to increasing throughput and reproducibility in experiments, particularly in the context of strain screening and media optimization?
Sure. So first and foremost, the Biomech is the easiest to use tip-based liquid handler on the market. I mean, without using complicated scripting, and I know that other liquid handlers can use things like Python, and we have access to that as well. One can get down to that granular level scripting to control our liquid handlers. But if you're a biologist, chances are maybe you've had a bioinformatics class or two, but having an easy to use graphical user interface to put together those protocols just makes hopping on to a system and making it make science just much easier. Now, once you integrate that BioLector XT onto the Biomech platform, you can start doing really cool things, like looking at, continuous fermentation over weeks, where you can remove, say, half the media, replace it with fresh media, and see how long your organisms can produce for. You can do things like advanced induction. You can even do some time point analysis where you throw in a fresh, clean microtiter plate and remove aliquots every couple of hours to see really how does your production curve look? What are your enzyme kinetics? I mean, these are all sorts of use cases once you start pulling that thread.
Uh-huh. Now, microbial fermentation labs can be complex environments. What kinds of strategies are you using to optimize workflows and boosting efficiency in these spaces?
So I've been talking about how this is a 48 simultaneous fermenters. 48, about 1 mil. We have a 2 mil reaction volume, and generally people are running between 800 microliters and 1200 microliters. But one can sacrifice the top 2 rows and use our microfluidics to move media and pH adjustment solution down those plates to start looking at, in an individually addressable way, how pH affects production, how timing of media affects production. Even things like we can control gassing from 0 to 100 with this system as well. Unfortunately, that does take place across the whole plate. We can't individually address gassing just because of the way the manifold is built. But we can manipulate all of these different variables. And once you're able to pull a couple of levers at once, you're able to really identify, what is making my bug grow.
Now, these fermentation processes, I'm guessing they're tricky to master. I mean, what are some of the common hurdles that you encounter, and how do you work around them to ensure successful outcomes? You mentioned earlier that you love getting out on the road and speaking to some of your clients.
I feel like the one thing that people wring their hands about frequently is scale. How do we scale? How do we know that this 1 mil is going to ferment the same in a 400,000 or 40,000 liter reactor or a 4,000 liter reactor? And we can't claim to be one to one with those larger reactors, but we do see really great equivalence when you take, your winner from your 1 milliliter, your 250 milliliters, your 3 liter. And once you scale, you do see a great divergence. And those white papers should be coming out a little bit later this year. They're currently in flight, or Q1 next year.
I find it, we're reporting on these technologies and these developments all the time. I find it amazing how these tiny organisms can create such big impacts. So I'm curious, what do you think the future holds for these microscopic workhorses, and how do you see them reshaping our world in the coming years?
God, that's such a good question. Here's the thing. We've been using modified organisms to produce things like insulin, really mission critical things since for a couple of decades now. And with things like CRISPR, Golden Gate assembly, a lot of the writing DNA techniques are really exciting now. And now that we're getting really good at that, you do have companies springing up in this space that really treat DNA like software. And again, this is, what the SynBio beta conferences are about, right? Is using that DBTL cycle to drive protein production or enzyme production. In addition to, let's say we want to make lactoferrin, or let's say we want to make casein, we can also start doing things that don't exist in nature. This holds such interesting potential for once we start doing things like, materials, chemicals. And I mean, not to deviate too far afield from the purpose of this call, which is really food-based, but, we can do things like next generation fertilizers to grow better feedstock. I mean, the possibilities are endless for technologies in this space. And I think that's what's really exciting about this space. It's like, it almost reminds me of like 90s era internet where, sure, there's always a kerfuffle and what happened to pets.com, this year has been a little bit of a tough year across all of the biotech sectors. But, I think that winners are being made right now that will impact the next 100 years of us as a people. And I think that, that's really exciting.
Hmm. So, as I understand it, the Biolector XT is a pretty versatile machine, right? It can handle a bunch of different tasks. But I'm just wondering, what kinds of things are people actually using it for most often? And when you team it up with that Biomech i5, what new possibilities open up?
Well, very related questions. I do think that how people are using this now is really as a middle ground between, really colony picking into a deep well block, grow or no grow, taking your growers from there, screening on the biolector, then moving to your 250 mil fermenter, with a winner selected from your 48. I think that it just allows people to take more shots on goal.
Mm-hmm.
And, if you're taking more shots on goal, you're going to make more goals. I think that being able to adjust and read pH, being able to read dissolved oxygen, being able to look at your optical density and your fluorophore growth curves, as a function of pH and feeding. I think that these really do fill that missing middle between a deep well block where it's just kind of set it and forget it on a shaker and needing all of that media volume for the larger fermenters. And again, integrating this onto an i5 really unlocks a lot of other more complicated types of manipulations while the fermenters are running.
Mm-hmm. Now, another bolt-on is a light array module, which provides a controlled and standardized environment for phototrophic microorganism cultivation. Can you describe how that system facilitates consistent light intensity, spectrum, and duration, which enables reliable and reproducible experimental outcomes?
Yeah, so the light array module sits in the biolector unit. This is an absolutely fantastic little device. It has about 16 different LED types in an array across the bottom of the plate, operating between 365 and 850 nanometers. So really able to dial into a whatever wavelength your microbe is liking the best. We have customizable day-night cycles, and it illuminates the whole plate. So you're getting good, even illumination. We've tested for edge effects, and our internal apps team hasn't seen any. But really, when you look at things like, lipid formation, this is really going to be impactful moving forward for groups in this space, because, algae tend to be a little bit better at making those lipids. So when you're looking at people who are like we hope to partner with the people in the synthetic palm oil space. That's really an impactful ingredient in terms of reduction of deforestation.
Mhm. We're going to talk now about the microfluid principle. Now, microfluidics has brought a miniaturization revolution to the lab. By shrinking the fermentation process down to microscopic scales, the biolector has opened up some exciting new possibilities. So let's talk about how this tiny technology is making big waves in fermentation. Can you explain how manipulating fluids at such a small scale has transformed traditional processes and led to these advances?
Sure. And I mentioned this a little bit earlier. When you sacrifice those top two rows, if you have your 6x8 plate, you're sacrificing your top two rows and you end up with four fermenting vessels in a row with two, typically one being media and one being pH. So those two will address the four vessels below it on the plate. The channels are operated via little pneumatic valves that open and close to force little boli at a time down into each of those vessels. And since we're taking a reading, say if you're trying to adjust a pH of a solution, we can add a little, check the pH, add a little, check the pH, add a little, check the pH. And so we're able to really tightly control pH using these. And, feeding, we tend to be a little bit more willy-nilly about, we'd like to, shoot in another 100 microliters of our glucose solution. But, these are great, especially if we want to start looking at like longevity. If we see growth sort of tapering off, we're able to address those.
Mm-hmm. Now, can you break down the connection between these fluidic systems, and industrial-sized fermentation tanks. How exactly does working at such a minuscule level help us achieve that larger scale production?
The one thing that we can't address, address is the pressure of these large systems. Once you have 40,000 liters just in a large vertical fermenter, the microbes on the bottom of that vessel are under an enormous amount of pressure. But again, as I mentioned previously, when we look at our winners at that 1 milliliter scale, it does trend. However, it's not an exact linear model. When there's pressure and oxygenation. I mean, sparging does a good job, but our flour plate really does a great job at getting oxygen into into those wells.
Now we're going to come on to real-time data, which is obviously critical parameter for optimizing fermentation outcomes. What key process variables are typically monitored to assess microbial growth, metabolism, product formation, and how do these parameters inform process control strategies?
Well, we can assess pH and oxygenation via optodes on the bottom of the plate. There's a little fiber optic bundle that travels the entire plate every couple of minutes. So you get really tightly time bin data there. And there's a clear window in the bottom of each well where we look at optical density as well as any fluorophore. And we have a number of filters for that, depending on what type of reporter you're using. But this is still significantly better than you're just throwing things into a deep well plate.
Mm-hmm. I mean, in terms of real-time monitoring of those parameters, which we know is essential for achieving those desired outcomes, what data acquisition methodologies are employed to capture and analyze those variables during the process, and how do these insights drive process control and improvement?
Sure. As I mentioned, that fiber optic bundle does travel to every single well in the plate about every 3 to 4 minutes. And all those data are logged in really easy to use and easy to parse tables. So you have all of those data about, the impact of your variables on your variable growth conditions on the actual growth of your organism. So we do have very tight time bin data out of this.
Mm-hmm. Now, we're obviously talking about the food tech sector, novel foods. It's all about sustainability. Now, what you guys, you're at the forefront of scientific advancement. We've talked about for the past half an hour. Your work is having a profound impact on health and well-being. How are you actively contributing to a more sustainable future while improving lives through your products and services and operations?
Well, Beckman Coulter is part of the Danaher family of companies. And we view sustainability as a fundamental responsibility. It's been a strategic priority of Danaher's more or less from the beginning. Danaher is a strange set of companies, but it was founded by two brothers who were fly fishermen, and sustainability was very important to them as well. Starting with water purity and water quality. And so we are shooting for a 50% reduction in greenhouse gases, scope 1 and 2 greenhouse gases by 2032. But continuous improvement is baked into everything that we do at the Danaher collection of companies. And we really are committed to sustainability.
Mm-hmm. Now, I just want to get your view of the wider food tech sector. What's particularly exciting for you out there at the moment in terms of some of the products that you've seen or read about?
I mentioned palm oil. That's really a great twofer, because not only are you preventing deforestation of typically rainforest where they are growing the palm oil, but you're reducing, again, every time you chop down trees, you're reducing the lungs of the planet. I think that specific proteins, I think that they're interesting, and I've tried a number of them. I think the ones that are there are several that taste great. I do think that one of the more interesting ones that I've eaten recently was the caviar proof of concept out of a UC Davis spin out. I think the texture is something that's still being worked on. And I think that for widespread adoption with the American palate, that's going to be something that needs to be a little bit more addressed. But when you look at, some of the cheeses where they do have that pull and they do have that mouthfeel, I think those are really exciting. So I'm really eager to see where this space goes.
Yeah. And thinking about the next 5 or 10 years, what do you see as the key challenges and opportunities for the industry?
Challenge again is going to be, some of those textures and also, there have been so many vocal anti-GMO people for so long that is going to be a significant hurdle to overcome. And so, it really is going to be a public education hurdle there that, these are safe foods to eat. They're nutritious, and they lower greenhouse gas emissions, which will move the needle for some people, not everyone. If once it achieves price parity, I think that, consumers are cost conscious. I think that we'll see a little bit more adoption. But, when you go into places like, Panda Express and you're seeing Beyond Orange Chicken, which is, something, one of those, you see it at every mall, that is a good indicator that these are foods that are being adopted. So that definitely gives me the warm and fuzzies. I think the Chips and Science Act and specifically the carve outs for building pilot plants, in the Midwest, when you look at things like IFAB, and even Heartland Bioworks to a certain extent, really looking at, these large scale production facilities. I think that those are things that can be really impactful because they'll create that vacuum where innovators need to start filling that space of like, I've got an idea. I've never known how to scale, but I know that ADM is one of the key strategic partners for that IFAB space out in Decatur. And so, I don't have to worry about scale. If I can get my molecule to a certain level, I can take this to a partner. I can take this to a facility that they can help me scale and help me dial this in. So I think that, there are a number of challenges, but there are also a number of opportunities here. I think that, as I mentioned before, this is a really exciting time to be in this space.
Yeah. Now, Beckman Coulter's role in that, how do you see it evolving to meet these challenges and capitalize on those opportunities?
I'm going to answer your question in reverse. Capitalizing on those opportunities sounds so vampiric, but the thing is, science doesn't happen by hand. It's not like Mendelian genetics anymore. Being able to transfer very small volumes is something that can't be done by hand. So, I think that Beckman Coulter is going to continue to listen to the market, via people like me and people on my team. We are going to go out in the field and continue to learn as much as we can about the market and continue to make sure that what we're doing aligns with what people want. That's the best that anyone can do. Yeah.
Great.
Did that answer your
Chris,
question?
I think it did. Yeah, I think it did. Chris, thank you very much for your time. It's been wonderful chatting with you. Very, very technical. Some of it may have gone over my head, but I'm sure it won't be going over the heads of our readers. So that's all right.
Thanks.
Thank you very much for your time.
Thank you. And thank you once again for having me. Excited to be speaking with you today.
Your enthusiasm comes across, and that's what drives this industry forward. So great to have you on board. Take care. Bye.